So the output is x, and we know that we're putting an input in, we're adding 14 to it, we're then multiplying all of that by 5, and that gives us x. So if I want to work backwards to get the input in terms of x, I'm essentially finding the inverse function, and what I would do is I'd have to divide by 5 to get back, and then I would have to minus 14, and that would give me my inputs. And therefore my answer for my input in terms of x is going to be x over 5. I'll write that as a fraction, and then minus 14 here. We're then told a number k is put into function a, the output is also k. Find the value of k. So what we're sort of saying is the output's k and the number's k, so I could say, right, I've got my output in terms of I've got my input in terms of my output now, so I can say that my input is k over 5 minus 14, and that actually is equal to my output. Sorry, my input. K. I'm getting this mixed up, but this is the input in terms of k, and now this is the output. So I can write an equation down and just set them equal to one another, and then I can solve this. I'm going to multiply through by 5. Sometimes you get asked to add 14 and then multiply by 5, but it's okay to multiply through as long as you're being careful. K minus 70, I have to multiply both of these terms by 5, essentially expanding brackets, equals 5k. And that's going to mean that 4k equals minus 70. I've just minused k and then I've flipped around the sides. And therefore k is going to equal minus 70 over 4, which is minus 17.5. Now that's one way to do it. The other way to do it is kind of ignore part A and say that, right, I've got k here, I'm adding 14, I'm timesing it by 5, and then that's going to equal k. Now if you notice, well, no, it's not so obvious. If I expanded this out, I would get 5k plus 70 equals k, and then I'd essentially be the same as this equation here. So I'm just saying that's another way you could have done it. I've used the inverse function aspect, but you could use the normal function aspect as well.